Good morning, students. Today we are going to discuss an important concept from metallurgy, that is concentration of the ore. What is meant by concentration? Removal of impurities like sand, clay from metal ore is called concentration. Removal of impurities from metal ore is called concentration. What are the impurities means? Sand and clay. Concentration involves several steps and selection of these steps depending on difference in physical properties of metal and gangue. So different steps we have, selection of step depending on difference in the physical properties of metal ore and gangue. We have different concentration methods like gravity separation, This gravity separation, well known as hydraulic washing. Hydraulic washing or levitation And another method we have, that is froth flotation and magnetic separation. The fourth one we have leaching process. So concentration of the ore can be done by gravity separation or hydraulic washing or levitation, froth flotation, magnetic separation and leaching. Let me discuss in detail about these methods. First one, gravity separation, or we are calling hydraulic washing or levitation. In gravity separation, what is the principle we are using means based on difference in gravities of metal ore and gangue. Gangue nothing but impurities. If gravity difference is there, then we are doing gravity separation. And this method we are using generally for oxide ores. Oxides ores can be separated, that is concentrated by this method. To concentrate by this method, we have hydraulic classifier, and the next one we have Wilfley washing table. By using hydraulic classifier and a Wilfley washing table, we can concentrate the ore by gravity separation. And let me discuss about hydraulic classifier. Hydraulic classifier. Hydraulic classifier is a large conical reservoir. Large conical reservoir. Here I am drawing large conical reservoir. It contains large conical reservoir. And this is hydraulic classifier. It contains a large conical reservoir and this is and with two inlets. This is top of the reservoir. We have one inlet, that is we are introducing the ore from it, and this another inlet we have here, bottom of the reservoir. We are introducing water from it, and two outlets, one gangue outlet and the another one we have concentrated ore outlet. This is the structure of hydraulic classifier, and there is a provision in this to remove lighter gangue particles from the top and to collect concentrated ore from the bottom. Then a powerful stream of water is introduced into the reservoir, and same time powder form ore is introduced from the hopper. Then we are getting suspension of ore. Suspension of ore. We are getting suspension of ore, and heavier particles of metal ore collected from the bottom and lighter particles, gangue particles collected from the top of the reservoir. And this is the method we have in gravity separation. And what type of metals can be separated by this method means like iron, gold, chromium. And here we have to remember that ore particles should be more denser than gangue particles. Ore particles should be more denser than gangue particles. Then this method can be applicable. This is hydraulic classifier. And Wilfey washing table, all of you know in your class 10 you already completed. And next method we have, that is froth flotation. So let me discuss about froth flotation. In froth flotation, What the principle included means? The principle is difference wetting property. Difference in the wetting property of metal ore and gangue particles. Difference in the wetting property of the metal ore and gangue particles. And here we have to remember that ores like sulfides means sulfide ores can be concentrated by this method, like lead sulfide, mercury sulfide, zinc sulfide. Means only sulfide ores are concentrated by fortification method. This is lead sulfide we are calling as galena, and this is mercury sulfide as cinnabar, and this is zinc glands. These are concentrated by this method. And here one more thing we have to remember, that ore particles should be low density. So this is a reverse to gravity separation. In gravity separation, ore particles are more denser than gangue particles. Here, ore particles should be in low density than gangue particles. And here the method we have how to extract by this method. And here we are taking along with ore plus oil plus water and a rotating pedal like this, use it to rotate. This is the arrangement. Here the powdery form of ore is mixed with water and then a suspension will be formed. A suspension of ore and water is taken in a vessel. To this, two types of chemicals are added. One is collectors. The next one is froth stabilizers. So suspension of ore and water is added by collectors and froth stabilizers. What are the collectors we are using here means collectors like pine oil, or you can use olive oil, camphor oil, whatever it is. Pine oil, fatty acids and xanthates. What are the characters used in this method? Pine oil or olive oil or camphor oil, fatty acids, xanthates. And froth stabilizers we are using. Froth stabilizers. we are using as aniline and cresols. Aniline nothing but amines, cresols. So this can make the method perfect. Now what are the activities of these collectors and float stabilizers? Float stabilizers. So here we are going to discuss in detail about this. So collectors we are using and float stabilizers we are using for stabilizers. How this will work? Here pine oil, what it will do means it will generate froth. So pine oil or any olive oil or camphor oil, it generates the froth. And froth stabilizer we are using as aniline or cresols. This froth will be stabilized. Froth will be stabilized. So pine oil generate froth, aniline or cresols are stabilize the froth. And here we have, that is xanthates, that is fatty acids. These are fatty acids and xanthates enhance the non-wettability. Enhance the non-wettability of ore particles. Ore particles. See, pine oil or any other oil will make the froth. Fourth stabilizers like aniline, cresols stabilize the froth. Then fatty acids or xanthates as collectors we are using can enhance the non-wettability of the ore particles. Then top of the vessel, froth is generated. When we rotate this pedal, this froth moving to the top along with ore particles. Along with ore particles. Because I told already, ore particles are having the low density. This froth is collected. This froth is collected into another, and then that will be dried out and recovering of concentrated ore is done. This is the method we have here in froth flotation. Froth flotation. But when ore consists two types of sulfides. For example, zinc sulfide and lead sulfide ore we have. When two sulfide ores are mixed in a particular ore, then this separation will be done by adding some chemical substances, that is, we are calling depressants. When the ore is mixed with two different sulfide ores like zinc sulfide and lead sulfide, one is considered as the impurity, one is as the ore. Then we are adding depressants. What type of depressants we are using means like sodium cyanide. sodium cyanide. Sodium cyanide is going to be used, and activators also we are using. Activators. What are the activators we are using means copper sulfate or sodium sulfide. Sodium sulfide. If the ore having two types of particles, that is zinc sulfide, lead sulfide, we are using depressants like sodium cyanide, and a activator also added, that is maybe copper sulfate or sodium sulfide. What this represent will do means it stop the impurities. For example, zinc sulfide is impurity. How can we know means which is less in amount, that is impurity, which is more in amount, that is ore. So this depressant will stop moving along with the froth. Moving along with the froth. These activators will help moving along with froth. So like this, depressants and activators we are using. When a depressant is added, how it prevent movement of ZNS along with froth means when ZNS treated with or ore is treated with sodium cyanide. Sodium cyanide means this represent react with ZNS and making a complex, that is sodium tetracyanozincate. Sodium tetracyanozincate. Sodium tetracyanozincate. So when zinc sulfide converted into insoluble complex like sodium tetracyanozincate, sodium tetracyanozincate, then it will not move along with the froth. But lead sulfide is moving along with the froth with the help of activators like copper sulfate and sodium sulfide. This is the froth flotation method we have. Next, magnetic separation. Magnetic separation. How magnetic separation is going to be carried out? Let me discuss. Magnetic separation method is very easy method. Magnetic separation. Magnetic separation. What is the basic property here we are using means it is based on differences in magnetic properties. Differences in magnetic properties of metal ore and gangue particles. So gravity separation is a difference in gravities. Froth flotation is difference in wetting property. And magnetic separation is difference in magnetic properties of metal ore and gangue particles. This is the main. Here we have an arrangement like these two magnetic rollers. Magnetic rollers. These magnetic rollers are connected with a conveyor belt. conveyor belt. These two are magnetic rollers connected with conveyor belt, and it is attached with a hopper. With a hopper. Hopper is the arrangement where powdery form ore is going to be introduced. So this is ore particles we are introducing here. Powdery form ore particles. So this is magnetic roller. Magnetic roller. And this is conveyor belt. Conveyor belt. And here we have collectors of ore particles and gangue particles. When powdery form ore particles introduced onto the conveyor belt, these are magnetic rollers we have along with a conveyor belt. It is moving on like this. Then the ore particles are moving along with conveyor belt, and this is a magnetic roller. If this ore having magnetic particles, those will be attracted and getting here near to the roller. If the ore having magnetic particles, that will be attracted by the magnetic roller and will collect here. Non-magnetic substances or particles are present. These we are collecting here. So this is magnetic particles and this is non-magnetic particles. Like this, we can collect magnetic particles and non-particles. And these are, we are calling gangue particles, and this is concentrated ore particles. Concentrated ore particles. This is magnetic separation. Magnetic separation. See, gravity separation, froth flotation, and magnetic separation. These all are physical methods. These all are physical methods. And another physical method we have, that is hand picking method. This is in our schooling. Sand, stones are picked out by hand. Hand picking method also physical method. By this method, what type of ores are concentrated means generally hematite. Remember, hematite is concentrated by hand picking method. Next, another method we have, that is leaching method. Leaching is a chemical process. That is chemical method. What is the main process here means, when ore is soluble in a particular solvent, if the ore is soluble in a particular or suitable solvent, then this method we are applying. What type of metals or ores are concentrated means, like aluminum ore can be concentrated by this method, silver, gold. Aluminum, silver, gold are concentrated by a chemical method called as leaching. Let me discuss what is included in this. Leaching of aluminum from bauxite. So leaching of alumina from bauxite. You know very well, bauxite is aluminum ore. You know formula for bauxite, Al2O3 2H2O. From bauxite we are extracting aluminum, means concentration of bauxite to get aluminum. What we have to do here is, ore is treated with concentrated NaOH solution, concentrated NaOH solution at 473 to 523 Kelvin temperature and 35 to 36 bar pressure. This is the condition. 473 to 523 temperature, 35 to 36 bar pressure. Then it will be getting into a chemical reaction. We are getting sodium aluminates. Sodium aluminates. Let me show it. Al2O3 2H2O. This is in aqueous position, and we have to add sodium hydroxide. Sodium hydroxide. This is also in aqueous position along with water, and this is in liquid. Condition is 473 to 523 Kelvin temperature, 35 to 36 bar pressure. At this position we are getting a complex sodium aluminate. Sodium aluminate. So here we are getting sodium aluminate. Sodium aluminate. This is sodium aluminate. So a complex sodium aluminate is going to be formed. A complex sodium aluminate is going to be formed. And impurities such as silicon dioxide, tin oxide, iron oxides are present in this ore. If silicon dioxide is present, this silicon dioxide reacts with concentrated sodium hydroxide and removed as sodium silicate. Removed as sodium silicate. Removed as sodium silicate. Then this sodium aluminate is neutralized by carbon dioxide. Neutralized by carbon dioxide. Sodium aluminate is neutralized by carbon dioxide. This is aqueous position, and carbon dioxide is a gas. It is neutralized by carbon dioxide. When sodium aluminate neutralized by carbon dioxide, we are getting hydrated aluminum oxide precipitate. Hydrated aluminum oxide precipitate. So hydrated aluminum oxide precipitate is going to be formed. This is hydrated aluminum oxide precipitate that is going to be formed here. Then from this, how can we get concentrated alumina means this hydrated aluminum oxide is going to be heated at high temperature. High temperature. Look here. Al2O3 XH2O is treated with at 1470 Kelvin temperature. Then this is aqueous. This is solid in form, and you are getting Al2O3 solid and water is going to be in it. This is the solid form. Concentrated Al2O3 is going to be collected. This is we have leaching process, especially leaching of bauxite to get alumina. Similar manner, we can leach silver and gold also. Silver and gold also. Silver and gold. Leaching of silver and gold. Leaching of silver and gold. Here ore is treated with silver ore or gold ore. For example, if you need silver ore, Ag2S, here we have silver ore, like that. Argentite, silver ore we have argentite. This is treated with a sodium cyanide or potassium cyanide in the presence of air. Treated with diluted sodium cyanide or potassium cyanide in the presence of air. Then we are getting respective concentrated ore. And this here we are cyanides we are using, that's why we are calling cyanide method. Cyanide process. And you go for it. Now, 4 moles of metal which is in solid position, 8 moles of cyanide which is in aqueous position, treated with air, nothing but oxygen. This is the reaction. Metal, ore, cyanide, aqueous solution, and this is oxygen. This is oxygen, gas. That's the reaction method. Then we are getting a metal complex. That is metal cyanide complex. Metal cyanide complex. I am getting. This metal cyanide complex which is in aqueous state. This metal cyanide complex further treated with zinc metal. And this is in aqueous and this is in solid position. When zinc is treated with this metal cyanide complex, you are getting zinc cyanide complex. Zinc cyanide complex which is in aqueous position and concentrated metal going to be connected here. This is leaching of silver and gold.